Okay, let's take a look at a simple Turing machine. This machine is designed to look at a string of capital A's and determine whether or not that string has an even number of characters in it. So I've got the machine built in what's called JFlap, which is a simulator that lets us run Turing machines. And I'm going to give it as input 4 A's to begin with. So what we should see at the end is that the machine says, yes, this is a string with an even number of characters. Okay? So we begin in the initial state with the tape focused on the first character of the input string. Q0 is the even state, which means that I've seen an even number of characters so far. Q1 is the odd state, which means I've seen an odd number of characters so far. And Q2 is going to be our accepting state, which we enter when the string is actually something we should say yes to. All right, so we start in the even state because 0 is even. Now, as soon as I read 1A, the transition says read an A, write an A, go right, move to state Q1. Okay, so you see that my tape head has been focused on the next character. I've read 1 so far, which is odd, so I'm here. Another step takes me back to Q0 through the read an A, write an A, move right, go to Q0 transition. Now I've read 2 A's so far, so I'm in the even state, and my tape head is here. The next 2 steps would be pretty much the same thing. Now I've read an odd number of A's, 3 of them, and finally an even number of A's, 4 of them. And now notice that the read-write head is over a blank. And I have a transition that says if you see a blank, write a blank, move to the right, and enter the accepting state, which means that this was an even length string. Click, and now this green shows us that the string was accepted, or that the machine says yes, the string AAAA has an even number of characters in it. Now, if we run it with an odd number, we can watch it give us the other answer. Okay, the first 2 or 3 steps are going to be very similar to what we've seen before. We start even, odd, even, odd. So right now, at this point, I've seen an odd number of characters, but the read-write head is over a blank. Notice that there isn't a transition for a blank from state Q1. So when I click step again, the machine is going to crash or blow up, which means that the answer to the question is no. The string AAA does not have an even number of characters. And there's our crash. Okay? And this works for any number of capital A's that you care to input. So if I don't input anything, I've got 0 A's, which is even, so it should accept, and it does. If I run it for a single capital A, that's an odd number, it'll go to the odd state and then crash, which means that it did not accept, which is how it should behave. And you can do that for any number of capital A's in your string. Now, if you happen to put in some input that is not what it expects, then the machine is just going to blow up right away and say no to the question. Okay? So this isn't very crash-proof or robust. It just takes the string and expects that it's going to be all capital A's, and then it does its counting based on that. All right, so that's a simple example of a Turing machine to determine whether or not a string is even or odd length.